So we have two mutually exclusive events here, and we want to see some probabilities. You've got a box that has 100 balls in it. 30 of the balls are purple and 10 are orange. If we select a ball at random, what's the probability of each of the following events? So we know that these two are mutually exclusive because a ball can't be both purple and orange. So we're going to draw a Venn diagram. It's really easy to do these with mutually exclusive ones with Venn diagrams because they don't cross. So we have purple and we have orange, and we have 30 of these purples and we have 10 of the oranges. And so how many other balls do we have? Well, we have 100 balls in there total, right? And we've only accounted for 40 of them. So we have 60 balls that have to be another color, right? We don't know what that color is, and it doesn't matter because, we maybe, if we knew more information, we would have lots more circles. We might have a blue and a red and a yellow in here, but we don't know the other colors of all the other balls. So we can just put 60 on the outside because that is, all we need. So what's the probability that the ball is purple or orange? Okay, so that means we've got the 30 purple balls plus the 10 orange balls out of how many total? Out of 100. So we have 40 out of 100, or 4 out of 10, or 2 out of 5. So we have a 2 in 5 chance of picking out a ball that is either purple or orange. What is our chances of picking out a ball that's not purple or orange? Well, this should be pretty obvious because it would be the opposite of that. So if we have a 2 in 5 chance of picking one that is, we'd have a 3 in 5 chance of picking one that's not. But if you want to see how that works, well, we have 60 that are total that are either not purple or orange, and then we have 100 balls all together, and that comes out to 3/5. Okay. What is the probability of A or B? So that's what we just did. And if you have two mutually exclusive events, then the rule of thumb is you can just add their probabilities together. Okay, so if they're mutually exclusive, meaning neither one can happen while the other one is happening, then if I just say, what's the probability of someone being a freshman and a sophomore, I can just add all the freshmen, the probability of being a freshman, and add it to the probability of being a sophomore, because there's no way that someone can be both. So if I want to find the probability of or, okay, this is an or problem. We have or problems and we have and problems, and we're going to talk about the difference later. But when you have an or problem where you're saying what's the probability of this or this, we look at mutually exclusive. And if they are mutually exclusive, then we know we can just add their two probabilities together. Now, the and part of it, if you're mutually exclusive, well, there is no and, right? Because they don't cross. So the probability of and is always 0 for any mutually exclusive ones. The other thing that we want to talk about here is the complement. And we already kind of talked about this. This is that notation of not A. So it's just the opposite of A. So if I said the complement of A, we would just be saying that's what's the probability of A not happening, okay? And that's what we did up here. We said the ball not being purple and not orange, we just looked at the complement of those. Okay, and really that's just 1 minus whatever the probability of A is, as you saw, because it's like if 2 out of the 5 balls is purple and orange, then the rest of them are not purple and orange, right? So 2 out of 5 are, 3 out of 5 have to not be. So we just subtract. All right, if A and B are not mutually exclusive, this is where we get a little bit of a problem, because if I said, what's the probability of picking someone who is in band and a freshman, then it's, or a freshman, then the problem is that if we say, here, we're just going to add all the freshmen together, right? Okay, so let's say we have 52 freshmen and we have 65 people in band. If we add these together, what happens to those people that are in both band and freshmen? Say we have 10 people that are both, right? So we have 10 people in this group. I have 10 people in this group that are freshmen and in band, and I have 10 people in this group that are freshmen and in band, okay? What happens when I add these two together? Well, I double count those 10 people. Let's look at it maybe on this instead. So if I said I had, what did I say? I had 50, 52 and 65. So if I have 52 and 65, but I have these 10 people in the middle, then I would accidentally double count them if I just add 52 and 65, right? So let's think about what that really would look like. Well, then I would actually have only 42 people here and I'd have 10 people in the middle, right? And then I'd actually only have 55 people out here. So if I just add these two together, if I just say I'm going to add them both, then I counted those 10 people twice. Okay? Does that make sense? I hope it does. If I just add them together, then I counted the 10 people twice because I counted them as freshmen and I also counted them as band members, okay? So what you have to do is, if you have two things that are not mutually exclusive, is you have to add the two probabilities together and then you have to subtract this 10. Because what I did is I added the 10 twice, really. When I added them together, see, I added the 10 twice. So I have to take away that double counting, okay? So basically that's just the idea. If they are not mutually exclusive, you have to add the two together and then take away how many people apply to both events, so that you don't double count